When graphing, we are trying to accurately reflect what data we are trying to express. So we need to look at the independent variable and y, the dependent variable and y, and just think of the overall expression that you're trying to give to your graph. So the first thing we need to look at is making sure that you have correct axes that help to display your information accurately. You need to make sure that you have a correct range in order to express your data. You're going to want to plot your data points as accurately as possible. And then you're going to look at the actual graph. Do you need to connect the dots? Do you need to insert a best fit line? Or would it be better to have a bar graph, pie chart, etc.? So whenever we are graphing, we're going to look at the 5 major parts of the graph. And again, we are trying to display the data that is collected during our controlled experiment. So our 5 parts are first the title. We want to make sure that the reader knows what the graph is about. Second, we have the independent variable. The independent variable is what we, the experimenter, control. It is what are we altering within the situation. Most of the time, this is going to be time or a measurement in length, for example, meters, could be temperature, for example, Celsius, and these are always going to go on the x-axis. Okay, then we have our dependent variable. That is what is being directly affected by the independent variable. It is what is happening because of what we have controlled with that independent variable. This is going to go on the y-axis. So for example, how many bubbles were created over a specific amount of time? Next are the axis and scales. Each axis needs to have an appropriate scale that accurately reflects each variable. Again, the x-axis will contain the independent variable, and the y-axis will contain the dependent variable. And last, you need a legend. What do your data points mean? If you're plotting, or if you're using a specific color, or if you have multiple sets of data on one data chart, what does this mean to the viewer? Next, let's look at some data and decide how we are going to graph. So here's our data table for the height of a plant based on the amount of fertilizer used. So we need to create a graph that's going to reflect both the x-axis and the y-axis accurately. So let's do that. So I'm going to insert a graph. You can either do this in a Word document, in Excel, or you could hand draw one. Next, I need to assign what I'm going to use on these axes. So if I look at the independent variable, the x-axis, I see that I am going in 2s. So I have 2, 4, 6, 8. So that needs to be reflected on my x-axis. So on here, I'm going to label my x-axis with grams of fertilizer. I'm going to make sure that I'm starting at 0 because I began my data at 0. And I'm going to go ahead and end at 10 so that I have a little bit of room. Next, we're going to look at our y-axis, which again is the dependent variable. So based on how much fertilizer is added, how is the height affected? So I'm going to title that with average height. Don't forget to include units. So in this case, we're using centimeters. Now in this case, we're going by 20s. So I need to reflect that in my data point. So I'm going to go ahead and go to 100. So I have a nice even data graph. And make sure that you're using approximately 75% or more of your graphing area. Okay, now this is a little crazy, so I'm going to go in steps of 10. Okay. So let's see what that looks like. I'm also going to make sure I show my labels. And don't forget we need an accurate graph title. So I'm going to have effects of fertilizer on plant height. Okay, let's save that. Now I need to make sure I can see everything. Oh, wrong one. Okay, so here is my complete data graph. Now I'm going to insert my data points. So I'm going to have at 0, we have a height of 20. At 2 grams of fertilizer, we have a height of 40. At 4 grams of fertilizer, we have a height of 60. At 6 grams of fertilizer, we have a height of 80. And at 8 grams of fertilizer, we also, once again, have a height of 80. And depending on the graph, we may want to connect the lines or we may want to insert a best fit. I'm going to go ahead and connect the lines. And what this shows us is that after adding 6 grams of fertilizer, there's no more effect on plant height. This graph also shows us that we had continuous growth until we had reached those 6 grams. Now in this case, we do not necessarily need a legend because we only have one source of data, but if I was going to be graphing 2 separate plants, I might have one in red and one in black, and then I would need to indicate that in a legend that I have 2 separate pieces of data that I am graphing. Okay, let's move on and try another graph where we might want to use a best fit line. In the case of this graph, we've got a water depth and a water temperature. So our water depth is on our x-axis. It's our independent variable. We are the ones that are taking the measurement at these different depths to see what the resulting temperature is. So whenever I look at graphing this data, I'm going to be inserting these in here. At 75. And at 200, I am at 4. So now I'm going to insert a best fit line. And what this tells me is that if I wanted to know at 100 meters what the temperature would be, I would go up to my best fit line and that would give me an approximate data point for me to record. So I would know at 100 meters depth, I should have a temperature of approximately 14 degrees Celsius. Most of the time in biology we will be using a line graph, but on occasion we will have separate pieces of data that we might want to look at on one graph. So for example, we're looking at the sport versus the number of students involved. And because we have so many different sports, we're going to use a bar graph in order to show that data.